All right, so people have been recently very afraid of sort of AI code generation and AI code generation capabilities. And in my opinion, I think that this isn't that big of an issue. In fact, code generation probably has been around since forever in computing. To see this, let's go all the way back to assembly code, like back in the old days where people only wrote in assembly code. We wrote languages like C, higher abstractions, to avoid errors in assembly and to kind of allow for us to have a better way to sort of view the program logic. And so we'd write in C, and then that would generate assembly code. That's what the compiler does. It's code generation. It's a code generation tool. Now fast forward to the internet. You have HTML, CSS, JavaScript running in the browser. All websites use this, and we need a way to sort of make this efficiently. It kind of takes a lot of time to sit there and build an entire DOM tree, build all the HTML elements, put in all the styling and those sort of thing. So we find ways to abstract this and make it more efficient. And so we make tools to generate HTML code for us. We create static site generators. Frameworks like React and Angular and Vue, like that's kind of what they are. They're code generation tools. They help us build HTML, CSS, and JavaScript code. You don't have to write exactly what you write when you're using one of these frameworks. You're not actually writing the entirety of the app. You're only writing parts of the app that have been abstracted away, so that it's more efficient to write these abstracted components. And those components can generate everything else. And so what's going on with AI is sort of like the next step of this, where I'm going to call it inductive. We have sort of a kind of an inductive computing rather than the sort of deductive computing of the past. So instead of taking like C code, you can deductively, given the type of an input, you can deductively go through and show what the output will be. But with a sort of inductive computing, which is my own term, it's just what I call it. When I give you like a type of an input, like a class that differentiates that input, what I get is actually a probability distribution of different types of outputs. And this is what AI code generation does. You give it some prompt, and even if your prompt is slightly different, you can have wildly different results. And even if you give it the same prompt, you can have different results with the exact same prompt. Maybe the better description is if I give it the same prompt twice, it'll give me two different answers. If I write C code, the same C code, and give it the same input, I'm going to get the same answer both times. In this case, like writing, we've always been writing code generation tools, and now we just found another way to do it. And this way of doing it comes with an error chance, which the previous ways didn't. I'll talk about AI agents in the future, but if you actually break down like what an AI agent is, it's basically just an API client. Like fundamentally, it's just kind of like if you ever built a server, it has the same logic. It's just sort of like a forever while loop, and you're just constantly, instead of constantly checking network sockets, you're constantly reprompting an AI model. And then you're just updating a database, which is just the markdown files, and you just feed those back into the server, that's the LLM, and you just sort of take in inputs and outputs, and you're connecting across various different APIs. It's like an API server, API client, depending on which direction you're kind of looking at it and how it's acting. This is not new. All we did is replace the internal server logic with an LLM's logic. This is sort of like almost like a server generation tool in a way, or maybe more like a client. Agents don't really act like servers; they act more kind of like API clients, right? And of course, it has its own issues. But this is just the thing as software developers. We've always been generating tools that abstract our workloads, and that hasn't resulted in a net loss of opportunities. If anything, the fact that web frameworks abstracted so much of the web development pipeline made it easier for more people to build web apps. You didn't have to sit there. Like if you could the same app that you built in React, you could build by hand, by scratch. But that's going to take so long. And so these tools made it easier for companies and apps and these sorts of things to develop. and be built. You know, as software engineers, AI is going to do a similar thing where it's going to allow for more companies to build systems and try to scale them. The problem is they don't scale, and I'll talk about this when I talk about AI agents. AI agents don't scale; they don't scale at all. These code generation tools, it's just like all these web frameworks. You know, before AI, everyone had to learn a web framework. Everyone was like, oh, you got to learn React, you got to learn Angular, because that's what's going to get you hired. Now it's like, oh, you got to learn Claude. Got to learn how to use Claude Code, because that's going to be the framework that everyone's using for code generation. I mean, I don't exactly think it might be Claude and all this stuff, but like that's kind of how this thing has evolved. It's just like any natural progression in anything in this field. Everything has been progressing in this way for a long time. Ever getting to the point where like we're doing prompt generation, we have like AIs generating prompts for us. That's just another abstraction. We just love doing this as software engineers. We just love building abstractions upon abstractions upon abstractions. You know, like and subscribe if you like more things. I'm currently rebuilding the channel, so there's a few hiccups. I'm not too worried about the direction. I think that I like making this content more, and if you like seeing it, just keep watching. Otherwise, have a good one.